Zoom, zoom, zoom. Hello, hello, hello. Hey, everybody, and hope you're having a wonderful day. Today, we're going to talk about rational number word problems. Don't freak out when you see the phrase word problems. It's really just, living the life. What's going on in the world? Let's go out there and be some detectives and solve some issues and fix some problems. Let's go, rock stars. You got to sometimes use the resources around you, like trees. And, how do trees get on the internet? They just log in. Log. Zoom, 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 zoom. Zoom, zoom. Trees log in. You got to get that. That's awesome. All right, so today we're going to estimate, solve, and justify using all kinds of understandings of addition, subtraction, multiplication, and division to solve rational numbers. I have a couple other videos on word problems and this whole theory of being a detective. I'm going to kind of fly through that today as a review, but if you like it and it's something you want to I want to use that. That seems like something to really help me. Go back and look at the videos on solving word problems. Okay, let's be detectives, all right? So solving word problems is all about breaking down the problem like a detective and finding the clue. Okay? So the first step in being a detective is you got to go to the crime scene, wherever this big thing happened, and you got to check out that crime scene and make it less complex. Just make it simpler. And so for word problems, we got all these numbers, we got these crazy words, and it sometimes it's 2 or 3 steps or 4 steps. Let's just make it simpler by kind of taking the numbers out of it and just making things a little simpler. So for example, if a salesman had 22 cars and then he sold 9, how many does he still have? And I know for some of you are like, yeah, this is a really simple problem. I'm only putting this down there just so you can see how you take complex and make it simpler. So again, if a salesman had 22 cars and then sold 9, how many does he still have? Okay, well, what's a simpler version of that? Yeah, a salesman had some cars. He gave some away. How many cars does he have now? Right, so we're not doing any adding, subtracting. We're not worrying about the numbers. We're just saying simply, he had some cars. He gave some away. How many does he have left? Right? So that makes it simpler. The next step is to identify any small clues. So if I'm a detective and I got this crime scene and I've made it a little simpler, now I'm like, where are my clues? Because I think all detectives are from England. Anyways, let's go look for some clues. And how do you do that? Well, we circle any numbers in the problem. So that's one part of the clue. We just circle them. We may not use them all, but let's circle them because they're clues. And then we underline keywords that will tell us if we should multiply, add, divide, subtract, or anything like that. So keywords are buzzwords. And so here's our problem. We're going to look at that here in a second. So some buzzwords have help a detective solve cases. So here's an example of some buzzwords. You've seen them in other videos and probably dealt with them ever since 2nd or 3rd grade. Like for addition, these are all buzzwords. Like if you see the word altogether or the sum of or the total number or added to or it was increased by, these are all addition, and there's a ton more. Subtraction, like difference is the answer to a subtraction problem, or the difference between two numbers. How far are they apart? Or I gave them away, or I sold, or she took them away, or how many more do I have? And these are all buzzwords for subtraction. Multiplication, its product is the answer to a multiplication problem, but like each and per, please pay attention to those. If you see the phrase each and per, understand that it's most of the time it's going to be a multiplication question, or there's going to be some multiplication involved. And the other times that it's not, it's more than likely going to be division, okay? So each, or the doubled or tripled, or it's twice the size, or you see the word of. Of is a good phrase or a good word to understand that we need to multiply. Okay, and then division, quotient is the answer to a division problem. Cut into, broken into, you share it equally, you divide it amongst, it's divided equally, halved, any of those are all buzzwords for division. So if we go back to our problem and identify the small clues that will lead to it, we're going to circle any numbers in the problem, and we are going to underline our buzzwords. So circle 22, that's a number. 9's a number, okay? So let's look for some buzzwords like sold. Sold. If I have something, I sold it, I got rid of it. All right. How many does he still have? That means it's referencing that there was something there and he got rid of something. How many does he still have? So there's 2 words right there that kind of give us a clue on what we might be doing for our problem. What kind of operation are we going to do? And in this case, if we gave something away or we sold it from our beginning value, we're probably doing what? Yeah, we are subtracting, right? So what's the next layer? The next layer of our problem is 2. Third step. Great detectives take all clues and design a roadmap. So for the roadmap, this does not have to be pretty. So don't freak out that, your teacher is asking you to be Mozart or like some Picasso, not Mozart, that's a musician, Picasso, and draw something special. But we just want to design a roadmap. All right. So what was our problem again? It was we had 22 cars and we sold 9. So our roadmap could look something like this. What did we start with? Where do we start in our roadmap? We had 22 cars. And then you could say, I took out of it 9. Okay. And I want to know, what do I have left? All right, so I've just sort of created a roadmap for myself, and I can say, I took it out, so I must have subtracted, and I know that looks horrible. My pen is not working very good today, so how many do you have left? All right, so that could be a good example of a roadmap. And then we just take our roadmap and we solve it. So if we had salesman had 22 cars and they'd sold 9, what would our situation look like? We would say 22. Okay, we would go back to our original idea. And we would say, let me do this in highlighter because it tends to make it look a little better today. So if I had 22, okay, and I sold 9, which means I got rid of them, I gave them away, I sold them, 22 minus 9 is going to be, I have 13. So I have 13 cars left over. And that's the answer to that problem. Now I told you that was a simpler problem. Let's look at a little bit harder, okay? In the Albemarle County School District, half of the students play a sport. A fourth of the students participate in the arts program. What percent do not pursue sports? Okay, so again, let's look at it. What's the simple version of our case? We have this school district. Some of them play sports, some of them do art. What percent doesn't do either? That's the question. All right, so I made it simpler. Next thing is identify clues. Let's look for some clues. So we're going to circle our numbers, okay? And we're going to look for some things that will help us solve this problem. What percent do not pursue sports, right? So if we have half of the students play soccer, 1/4 of the students participate in the arts. So it looks like we have these two things. These two phrases are telling us that we have a half and a fourth that do something. And we want to know what section does not. So these two phrases kind of lead me to think we're going to add those two together, because we need to figure out what's left over, right? What percent do not? That tells us that we're going to eventually have some sort of subtraction situation going on, all right? So the next thing, so I've identified the clues. The next thing is, let's draw our roadmap, okay? So how can we draw a roadmap? Well, we can say that we have sports. Let me go back one. We can say we have sports, okay, plus arts, okay, equals this number of people that do sports and arts, okay? And we want to figure out from that what percent don't. All right, so we know we're going to add these together so we can figure out the total amount of the district that does it. And then we're going to figure out what doesn't do it so we can find the percent, okay? Well, let's look at what that looks like. So let's go ahead and break down, use our data. Let's use our information that we have, use our clues. Well, we said that sports was 1/2. Half of the school district does sports. 1/4 of the school district is involved in the arts, okay? So we know that. So remember we said in our roadmap we were going to add those together. So I know that I can't add fractions together if they have different denominators. So I went ahead and turned my 1/2 into 2/4 because I know that 2/4 and 1/4 can be added together. I knew that that was going to be my common denominator. And when I add them together, now I have 3/4. So I know the total amount of, not the total amount, but the total as a fraction, what fraction of our school district does sports and arts. All right, so if we know 3/4 of our school district does sports and arts, we know that the whole school district would be 4/4, right? That's all of them. Any number over itself means 1 or the whole or the 100%. So this is the same thing as 100% of our school district. Now, what am I taking away from that 100% of the school district? Well, I'm taking away the ones that play sports or arts, and that would be 3/4 of them. All right, so now we know if I had 4/4 of the school district, all of them, and 3/4 of them play arts or do the arts or play sports, what's left over? Well, it's 1/4. Again, now why did I choose 4/4 here? I could have put any number over top of it. I could have been 7/7, 52/52. I could have just put a 1 there. But since my answer was in fourths, I wanted my whole to be in fourths. So that's why I put 4/4. So it's easier to subtract. If I have 4/4 and I get rid of all the arts And sports characters, I have 1/4 left over. And our question is not what fraction, it's what percent. And what does 1/4 represent as a percent? Well, that's one of our benchmarks. 1/4, you can also say a quarter. A quarter of a dollar is 25 cents. A percent, 1/4 as a percent is 25%. And there's our answer. 25% of the students in Albemarle County do not play sports or do the arts. Totally made up numbers. I don't even know if that's anywhere close to right. All right, so the next, when I say not close to right, the math was right. I don't know if half of the people play sports or 1/4 of the people are involved in the arts. So now we got these two characters called Miles and Chandler. They went shopping for candy at the local store. Miles focused on chocolate, and that cost 40 cents per pound. Chandler focused on chewy snacks. Those cost 50 cents per pound. Miles bought 7 pounds and Chandler bought 6 pounds. Who spent more? Okay, so for this scenario, we want to figure out who spent more on these on the candy. So the first thing is simpler version. All right, a couple kids went to a candy store to buy some chocolate. One of them bought more pounds than the other, and one of them the per pound cost a little less. All right, so we're just like, and then who spent more money? That's what we want to know. What are the clues? Well, we go in and we circle our numbers: 50 cents, 40 cents, 6 pounds, 7 pounds, and we look for buzzwords. Here's a buzzword right there. Per. Remember I told you per? That's really important. We want to know about per because that normally means multiplication. And the cost, oh, here's another per, 50 cents per pound. All right, who spent more? Okay, we're going to try to figure out which one's bigger than the other one. Who spent more? All right, so let's put that into a roadmap. Well, we want to say, Miles. We're going to take whatever Miles has, his amount of food that he bought. And since we know it's per pound, we're going to take Miles' candy and multiply it by what? Miles bought 7 pounds. We're going to multiply it by 7, right? Because we know it's 40 cents for that, and we're going to multiply it by 7, and that's going to give us his total. And Chandler, we're going to take however much candy he had and multiply it by 6, because Chandler bought 6, and it's per pound. You see how these roadmaps kind of work? All right, and then the last thing we're going to do is go ahead and solve this bad boy, okay? So let's solve it. All right, so we have Miles and Chandler. I set myself up a nice little pretty table. Okay, Miles' candy was 40 cents per pound. Chandler's was 50 cents per pound. Miles bought 7 pounds. Chandler bought 6 pounds. Okay, and what did we say we're going to do to those? We're going to multiply them together. So Miles at 40 cents per pound times 7 pounds is $2.80. You could do that on a calculator. You could have went over on your sheet of paper and solved it, blah, blah, blah. Well, that's what it equals, $2.80. And Chandler bought 50 cents worth of his candy cost 50 cents, and he bought 6 pounds of that candy. So he spent $3. Again, calculator, whatever it is that you're allowed to do for this type of problem. And who spent more on this situation? Well, Chandler did. He spent $3. His candy was more expensive per pound, and he bought less pounds, but it still ended up being that he spent more money. All right, I think you guys are ready to rock and roll. What's a tornado's favorite game? Twister. You guys ever played the game Twister with all the circles on it? Well, that's what tornadoes play because they're a twister.